Hello everyone. So in this particular video we are going to look at the collate function in Pytorch. So in this particular video we will see what collate function is and also try to understand and write our own custom collate function in Colab after some time. So without any further ado, let's get started. So what is collate function? Well, collate function is nothing but a data loader parameter. So if you remember, we used to write data loader where first argument used to be our custom class, then second we used to have batch size, third we used to have shuffle equal to true and false or false, and one of the functions was also collate function. You can also see in that class, you can see there is something called as collate underscore fn, which is collate function. Now why it is used? Now it is used for three purposes. Number one is to stack data other than the first element, so first dimension. So if you remember, when we used to do cats versus dogs, and the data that we used to get was something in this format: 16 comma 1 comma 16 comma 3 comma some height comma width of images. So 16 images, all of 3 channels, and then height and width. So that 16 was given by the data loader because it was the images were kept in the first dimension. So that is the first use, and we will not be seeing that right now because we have already seen that in the previous videos. We will be focusing on the second aspect, that is to stack data of different lengths, and we are going to see a live example. Or also include code it into the Colab. And the last one that we are going to see is, we may not see it, but we will see it in the next series of object detection. That the third purpose is to put data together which are of different data types. Okay, so we will be using this, I believe, in faster RCNN. That is something we will be looking at the next your series. Okay, so let me take an example over here. So the first, what we have is we have 5 sentences, and here I have written the length of the words, length of the number of words. Okay, number of words in each sentence. So first sentence is hi there, and you can see there are 2 words, hi and there. Let me get the marker out. So we can see there is hi and then there is there. This one has 5. Let's go outside to play. So there are 5 words, so length is 5. And similarly, you can see I like eating samosas, I am outside, let's start eating samosas. 4, 3 and 4. Okay, so we will be using these sentences for our program. So what initially has to be done is we will be using the encoding. So as you can see, there are 5 sentences, and then what we will do, we will tokenize it. Basically take individual words like hi, there, and whatever the individual unique words are there, we will be taking them and we will be writing like this, and then we will have some embedding. So we are having, for each word we have 4 dimensional vector. So hi, this is the this particular vector is there. Then for the word there, this particular vector is there, and similarly for all of them. Okay, now let's try to have a batch size of 2. Let's say we were having 5 sentences. Let's say in the data loader our batch size parameter is equal to 2. So what will happen? So if you see, if you do a sequential sampling, this will be 0, this will be 1, and if you say like batch size equal to 2, then these two will come out. Now what is the problem with that? See, this one has length of 2, okay, and this one has length of 5. So if you are going to see hi there, and we are going to write the embeddings like this, so this one is going to be embedding of hi. So this one is hi. So you can see 0.29 minus 1.717. Here you can see 0.29 minus 1. So hi is this vector and there is this vector. So as you can see, hi is this vector and there is this vector. So you can see the dimension of this is 2 cross 4. See, it has 2 rows and 4 columns. So 1, 2, 3 and 4 columns. And one that I have added is something that data loader itself adds. Okay, so it is one example, and with each and for the first example, or the example has 2 rows and 4 columns. However, you see the second sentence, let's go outside to play. You see there are 5 rows, right? There are 5 rows, 1, 2, 3, 4 and 5, and the columns obviously remain same. And since this is also one example, now I want to state that there is a problem. The problem is you will not be able to concatenate it, which is, if you are able to which is you cannot concatenate. Why? Because this is 2 and this is 5. This will give you an error. You can try it yourself. So what is the solution to that? The solution is called padding. You pad the smaller sequences to match the bigger ones. So how we are going to do this? Well, in this case you can see it is 2 cross 4 and this is 5 cross 4. What happens is this 2 cross 4 will be padded with zeros. see over here zeros. Now this is also 5 cross 4. Why? Because we have added the padding. There are 5 rows and 4 columns. Now this again leads to another problem. That is, it has too less information, only 2 rows of information and too much padding. That is 3 rows of padding, which means that the padding is more than the information. So how can we actually solve the problem? Well, the final solution is this. What you need to do is you need to sort the data set, and we will see how this works. Okay. So we are going to sort the data set in the increasing number of words. And the second thing why we are going to do this is because we need to minimize the padding. We will see how it happens. Second, we will pass sequential indices, because obviously if we have sorted, then it has come in a particular order. So if you do not pass sequential indices, which is if you again query randomly, then the total plan, or rather the total incentive, or rather the total I'm not getting the right word. The reason for sorting will be destroyed. Okay, it will be cancelled. So we are not going to use shuffle equal to true. We are going to pass sequential indices. And thirdly, that is to add the padding, which we saw the last time, to be able to stack the embeddings. We will see what it means in the next slides. So initially we had this, right? So the first step is to sort the data set. So we can see 2, 5, 4, 3, 3. This is not sorted. So once what we do is we sort all the sentences. So now you can see this is sorted 2, 3, 4, 4, 5. This is in the increasing order. This is step number 1. Now what is step number 2? We will pass the sequentially. Obviously this has to be the sequential numbering has to be done through the data loader by passing shuffle equal to false. So what you do in the data loader, there is a shuffle parameter. If you say false, then sequential. I have explained sampler and everything. You can see in the channel, it's already there. So we are going to have the first two statements or sentences, and see the width are now, the length are now almost similar, 2 and 3. Now what is the second step? Before that, you can see this was our embedding. So this was for high, and this was for there, and then you had 1 cross 2 cross 4, and I am outside had 3, 1, 2 and 3. You can see 1 cross 3 cross 1 cross 3 cross 4. Now what we are going to do is we are going to pad one over here. Now what we did, we padded one extra row. Now this became 1 comma 3 comma 4, and this was already 1 comma 3 comma 4, which means as you can see, high there has it initially had 2, we added one more, now it became 3. So 3 rows and 4 columns were obviously there, and I am outside had 3 rows and 4 columns. So you can see now these two they match. Okay, over here you can see 1 3 4 and 1 3 4, they match. Now what will happen if you do concatenate? If you do the concat function from Pytorch, you can see 1 3 4 and 1 3 4 with dimension at 0, you get 2 comma 3 comma 4. So this is now our batch. And so our batch number 1 looks like high there and I am outside. And in the number terms, how it will look, you can see 3 rows over here, 3 rows, this is the padding row, 4 columns and 4 columns, you can see over here. So 3 comma 4, and there are two such, this one and this one. So there are two of them. So 2 comma 3 comma 4, and this is what the data loader will pass to the training function. Okay. Now batch number 2, this is simple because these both of these have the similar number of words, so you don't have to do any kind of padding. Both will be 4 cross 4, and this one also 4 cross 4. You will directly concatenate it 1 comma 4 comma 4 and 1 comma 4 comma 4 in the dimension of 0. You will get 2 comma 4 comma 4. Okay, again if you look at the data, how the data will be, it will be like this. Okay, sorry for the noises outside. So batch number 3, since it's only one statement, so it will just go like this. It has 5 and it will be 1 cross 5 cross 4. So that was the basis of collate function. Now we are going to implement it in code. Okay, so let's now implement the custom collate function. So for that we will import numpy as np, and we will also import torch. So after this, what I have done is basically I have written all the sentences from before so that I don't have to write, and also did one more thing. I have implemented the sorting already, so all these sentences are already in increasing number of words. Okay, so high there has smallest number of words, and let's go outside to play has the maximum number of words, so that we can focus more on the PyTorch and custom collate part and not on the sorting the sentences part. Okay, So after that, what we need to do is we need to find the unique words. So for that, we are going to say unique words equal to, we are going to say np.unique. So np.unique of, what we are going to do is basically we are going to join all the sentences first and then going to split. So what this much of code will do is it will join all the sentences using a space, a blank space. And what split will do is basically take all of those, the whole sentence which we will get over here, and split them on this, so to say, blank space itself. So now what we are going to get, and then we are going to take the unique of that. So we will have a list of all the words, and then we'll be taking the unique of that. Basically we are going to have the unique words. So if I'm going to print the unique words, I should get all the unique words over here. You can see the unique words are there, and if you remember, the length should be 13. If you have seen the slides, yes, we have the length here. Now what we are going to do, we are going to basically say, let me have this as number of words. We will be needing this later. So we are going to say len of unique words. Okay, after that, what we are going to do is we are going to have an embedding. So we are going to say emb as equal to torch.randn, and the way we are going to have it, how many of them, number of words, that many words, and each word is going to have 4 numbers associated, for a list of 4 tensors associated. So if I am going to print this, what I'll get is something as 13 cross 4. So there are 13 rows, as you can see. This is the first row, this is the second row, and 4 columns. You can see 1, 2, 3, and 4. So if you print the shape, also you're going to get 13 cross 4. Finally, what we are going to do is we are going to have a mapping. What mapping is, let me just scroll down. So that will make it more concrete by saying, if you don't understand zip and all, videos are there on this channel, you can go and see. So what it is going to do, basically I'm going to explain what it will do is, it will take each and every word. So it will take unique words and then associate an embedding to that. So we are going to say EMBS. Okay, and if you are going to hit enter, shift enter, sorry, and then let's print mapping. So we will see the output. The first word was high, and it is associated with this tensor. Okay, second was I, and now it has this tensor, and so on and so forth. So for all the words there is a tensor associated. So this will actually help us in the training. After this, what you are going to do is we are going to describe the, or rather define the custom dataset class. So we are going to say cust.torch.utils.data.dataset. We have already seen dataset in our Pytorch course, and then I'm going to say define def self, and I'm going to send 2 things. I'm going to say sentences or sends, and I'm also going to send mapping. Then I'm going to declare self.sends equal to sends, and self.mapping is equals to mapping. Okay, after that we needed a len function. So underscore len, we are going to pass self in here, and then we are going to say return length of self dot sent. So how many ever sentences are there? Obviously it is 5, so this will be returning 5. So because 5 were the number of sentences. Now what we need is we need a get item, and we are going to pass self and 1 index. Okay, now here what we are going to do is basically we are going to have all the, first we are going to take the individual sentence. Okay, whatever index is passed, we say sends or idx. So this will give us the sentence. Now what we are going to do, we are going to basically break it into words. So our words will be sent.split, and yeah, that's enough. So it will be split on the space. Let me also provide that, but it was totally optional. So I'm going to have 10, which is basically our tensor. Okay, it will be our tensor. I have initialized it to none because we will be filling it later. So what we are going to do after that, let's say if 10 is none, which basically means that we have, or for, I've forgotten the for let's say word in words. So what it will do is for every word that is there in words, it will check if 10 is none, which means that it is the none, which is the first iteration. Means we are yeah, this is our first iteration. What it will do is it will say 10 equal to self dot mapping of word. So what was self dot mapping? So it took individual words. You can see over here self dot mapping is here itself, mapping. It took individual words and associated it with the tensor. It took a word and had a tensor associated with it. So whenever over here you pass a word, it will give you back the tensor. Fine. Now what we are going to do? We are going to say else. Else meaning this is not the first iteration. Some iterations have passed. So we are going to say 10. We are going to say torch.cat. Cat is concatenation. I hope you know. Or better, instead of concatenation, let's have vstack itself, because it will it's basically the same thing, but it will help us write lesser code. So we are going to say 10 and we are going to say mapping, okay, and then mapping of word. So, or rather self dot mapping of word. So what this will do is whatever tensor we have, it will vstack, vertical stack the next word. So if you have something like let's say over here, if you have already something like 1,4, because 1 was for a particular word high and then 4 is embedding, what you do with the vstack, you added another self dot mapping, which was again 1 cross 4. This add does not mean a pointwise add or anything, okay, and then it will mean that after vstack it will become 2,4, okay. So it's basically I've explained in one of the videos, top 10 Pytorch functions. You can go and see I have explained what vstack does, okay. So having done till here, let me go and return the tensor, okay. So let me particularly run this for one, because that I'll be sending sends, then mapping, and let's get item for 0. Let's print this one. So you can see hi there was the first word and this is our mapping, okay, first sentence, sorry, and this was our mapping for this is our tensor for hi there. Let's see what we get for 1. So 1 was the sentence was I am outside. You can see over here the first sentence is I am outside. This is the 0th sentence, or yeah, this is the, yeah, I'll just say the index. This is the 0th sentence, this is the first sentence, I am outside. It has 3 words, right? So here you can see it is 3 rows, and again every word had 4 columns, so it has 4 columns. Now what we are going to do is, let's remove this. Now what we are going to do is we are going to define the data loader. So we are going to say DL data loader without collate, okay. DL is data loader. We are going to say torch.utils.data loader, and then what we are going to do, we are going to pass the custom dat function, custat. We are going to send the sends and then mapping. After that, what we are going to do is we are going to go to the next line and say batch size, and we saw in the video, let's have it 2, and here we will not be having any collate function, okay. So we will just say shuffle equal to false, because we don't want any shuffling. Let's run this cell, okay. Now in order to get data, what you need to do, you need to define an iterator. In a loop you don't really do it, because it it processes in itself. However, if you are not using a loop, you need to have a iterator. So I am going to say it equal to iter of DL without collate, and I'm going to run this cell. After that, what I'm going to do, I'm going to get the data next, okay. Now I expect an error over here because we haven't used collate function. So let's see, we get an error. Yes, we got an error, and the error says stack expects each tensor to be of equal size, but got 2 cross 4, which is high there at entry 0, and 3 cross 4, I am outside at entry 1. As I explained in the slides, it is not possible to concatenate them. Okay, now let's go and implement the data loader with collate function, okay. So I'll go and copy this, remove the without and keep it to width, and now we are going to define something, custom fn is equals to custom, or rather collate fn, collate underscore fn equal to custom collate, COLLATE, okay. And here I am going to define the custom collate, okay. and then we are going to pass in the data. First thing that we'll do is print the data to see what actually is going to give it to the. Okay, for that what we need to do, one more thing is with collate dot. So I'm writing it in one line only so that I don't have to write multiple lines. Okay, so we are seeing we have a list. Okay, it's a simple Python list. First element is this, which is 2 cross 4 tensor. Obviously it is for hi there, the first sentence, if you remember, hi there. And the second one is I am outside, which is 3 words. So you can see here also you have a tensor which is 3 cross 4. So the first thing that we need to do is we need to find the maximum length. So we need, in this condition, what we have to do, we have to pad this to 3. Right now it is 2 cross 4, we need to pad it to 3 cross 4 because this is 3 cross 4. So we need to find the maximum in every case. So we will say max mx equal to none for I in range whatever is the length of data, and then if mx is none, that is for the first iteration, we are going to say mx equal to len of data of I. That's it. Data of I dot or not len, let me just say data of I or data of 0, whatever I will be 0 in this case, dot shape of 0. Okay, else means one this is second and further iteration. We are going to say, or rather say elif mx is less than data of I dot shape of 0. We are going to say mx equal to data of I dot shape of 0. So let's return this and see what we are getting. So in the first case, let's see, we are going to return mx and then let's see what happens. So it's taking some time to run, but what I ideally expect is I'll get 3. Why? Because if you remember, the first one was two letters and third one was 3. So if you have like whatever is the maximum of all the letters, that will be given. Okay, because that much amount of padding needs to be done, so that whatever amount of padding needs to be in the final answer should be the maximum. Okay, so let's say the first sentence, okay, that is for hi there. In this case, dt is going to be our the tensor, the final tensor. So let me actually keep it above this. So we are going to have dt equal to none. So for the first sentence, we are going to calculate something called as rec. So rec is maximum minus data of 0 dot shape of 0. So max mx was 3 and data of 0 is of shape is 2 cross 4, and what is the 0th element of 2 cross 4? It is 2. So 3 minus 2 is 1. So the requirement of padding, that is rec amount of padding, is 1, rec equal to 1 in this case. So if dt or dt will be none, right? So what we are going to do is if rec double equal to 0, which means in this case there will be, if such a data is given where there is no requirement of padding, that is rec equal to 0, we are going to simply say dt equal to data of 0 of let's say we are going to do a increment in the dimension. Now why it is done? So if you remember, we were having something like 2 cross 4 for hi there, but if you remember from the slides, we had converted into 1 cross 2 cross 4 initially. After that, what we did, we basically first converted to 1 cross 3 and then converted it to that. However, if no padding is required, that is rec equal to 0, then we can directly do it. So we can say, we'll just keep it like this. So what we have done is we have incremented the first dimension here. That is what this does. Okay, else, that is when rec is not 0, you have to do some kind of padding. So we will say temp equal to torch dot, what you going to say, cat, and after that what you are going to say, we are going to say data of 0. It has to be padded with what? We have to pad it with zeros. Zeros of what dimension? Rec dimension cross 4. Why? Because rec is the number of rows that we need to add. And in which dimension we will add? We'll add at dimension of 0. Fine. So after this, what we are going to do is we are going to say dt equal to temp of, and again increase the dimension. Okay, so this was for the first sentence, and then for rest of the sentences, for rest of the sentences, what we are going to do, we are going to run a loop in range. We are going to run it from 1 because we have already done the first sentence. So from 1, index 1, we are going to start, and we are going to length of data, that means for every sentence, and we are going to first find the requirement. So we are going to say mx minus data of I dot shape of 0. So for every sentence we will see whether it has maximum number of rows or not, otherwise we will have to pad. So what it says, if rec equal to 0 means no padding is required. So we will just say dt equal to torch.cat. Okay, torch.cat, and after that what we are going to do, we are going to basically say that we will up data, and we will say torch dot, or we will say data of I. So dt was till now whatever we have, then data of I, and we are going to say that we need to increase the dimension, and from at dimension equal to 0. Okay, so this is the case where req is 0, that is we don't have to do any padding. However, if you have to do some kind of padding, we will say temp equal to, first we'll pad it dot cat torch.cat, and what we are going to pass here is we are going to say data of I, and what we are going to pad with, we are going to pad with zeros. How many? Rec comma 4, and we are going to pad in the 0th dimension. Fine. After that what we are going to do is we are going to say dt, which is finally what we are going to say is torch.cat. Cat is concatenation, if you are not already knowing this, and then we will be saying temp. Okay, temp none and triple dots, and this one also has to be in the 0th dimension. Okay, and finally we will return dt. Let's run and see what we get. Okay, we are returning dt. Okay, max. So now let me run this. Okay, fine. You can see that in the first case, hi there, 0 has been added, one extra dimension has been added. So let me do for all of them. So we'll say it2 because we already have it1. So this is the iterator for DL with collate, and you will see you will not get any errors, and we have already seen, but again you're going to say the same thing first. So this is going to be your hi there and I am outside. So hi there was 2, we have appended or concatenated one one vector of 1 cross 4 of zeros, and this was I am outside. So now you can see it easily run because they were of same dimension. What happens if you are going to again run it, again get another batch? So it2 dot next, and you can see here 4 cross 4, and this one is also 4 cross 4. So if you remember, there were two sentences of the same length, so no padding was required. I like samosas and I start eating samosas. Let's start eating samosas. So you can see here there is 4 cross 4. Okay, no padding because they were both of same length. Lastly, if you again do it, you'll get only one. You'll get only one because there was only one sentence. Okay, so this was for your custom collate. If you have any problems or questions, go to the comment section, or also message me on Instagram. I check Instagram a couple of times a day. If you want my help on any of your projects, then you can go to my Fiverr and take my gig. It's really cheap, $5, and you can have a one-to-one video discussion with me. And yeah, thank you very much, and bye.